Good morning. So let us start the next lesson, the sum of two trigonometric functions. This is the title that the book has used, but they're only talking about the sum of sine and cosine, yes? So let me just try to motivate you a little bit. So for example, if I ask you, if I give you a function like this, y equals to 2 sine x, if I ask you what is the maximum of y, what would be the answer? What is the maximum of y for this function? Yes?
2.
2, yes, because the sine maximum is 2 and the minimum is minus 2. Okay, so if I, let me make it simpler. If I give you just this function, I ask you what is the maximum, you would say the maximum is 1, the minimum is minus 1. If I ask you the same question for this function, the answer would be the same. The maximum is 1, the minimum is minus 1. Now let us sum the two trigonometric functions here, add them up. So I have sine x plus cosine x. And I ask you the same question. So what is the maximum of this sum now? Yes?
2 again.
No. That is usually the good motivating question, because you might think that the maximum of sine is 1, the maximum of cosine is 1, then you would answer, okay, it's clear, the maximum of sine plus cosine is 2. But do you think why 2 is wrong? Yes?
Because if sine is close to 1, then cosine gets...
Yeah, that's the point. So you cannot make both of them close to 2, close to 1, so that the sum becomes 2, yes? So if you want to make this sum, when you say the maximum is 2, it means that you can make this to its maximum, which is 1. You can simultaneously make this to its maximum, which is also 1. Then, of course, the sum of these, the maximum would be 2. But this cannot be done simultaneously, yes? If I start increasing sine, then at the same time I have to decrease cosine, yes? Because if this is my unit circle, so you see, for example, if this angle is x, if I want to increase sine, I have to go higher because sine is on the y-axis. But if I go higher to make sine bigger and bigger, so here the sine is this amount, but here the sine of course is bigger, but the consequence is that cosine was this amount, but now cosine is smaller. So we need to find the optimal point to make this maximum. So is that understandable? So the answer, the naive answer that the maximum is 2, we can say 2 is an upper bound. This is for sure that sine x plus cosine x cannot be more than 2. That is for sure, but this doesn't mean the maximum is 2. When you say maximum of a function is a number, it means that number is attainable by the function. So it means that can you think of a number for x, of an angle for x, so that when I put it here it becomes 2? The answer is no, because the maximum of sine is 1, the maximum of cosine is 1. To reach to this number, I have to make this equal to 1 and this to equal to 1 simultaneously, which is not possible. Yes, I cannot find any angle so that when I put it here, the answer becomes 2. Yes? Okay. But now the question is that what is the maximum of this function and what is the minimum of this function then, if it is not 2 or minus 2? Of course, we will be able to answer this question using derivative. So whenever we want to find the maximum or minimum of functions, we use the notion of derivative. At this point, you don't know how to do that because you haven't studied the derivative of sine and cosine. That would be the topic of the next chapters. But there is a better way, there is not a better way, there is another way for this special function that we can find its maximum and minimum without using the notion of derivative. Yes, so that is one way of studying this function. Okay, but now let us make it more general. What happens if I multiply them with numbers? So the thing that we want to talk today is not this function, it's the most general case of these type of functions. So we want to study this function. Y equals to a sine x plus b cosine x. Of course, if I take a and b equals to 1, then I can see that this would be this function. Okay, so here my goal is to study a little bit about this function. And here a and b are numbers, but of course I will not take them 0, because if a is 0, what I am left is just cosine alone, and if b is 0, what I'm left is just sine alone. We have already studied them, so there is no point of studying them further, yes? So the only thing we need to understand here is that a is not 0, b is not 0. Because if they are, we go back to the previous lesson, which we don't want to do that. So I assume that a is not 0, b is not 0. For technical reasons, I have seen what is written in the book. It is not that complete. I will talk about that. So let me just go to the most general form of that. I will consider for the time being that a is positive and b is not 0. Okay, so let me consider this function with these properties. A is a number which is positive, b is any number which is not 0. Then we want to discuss about this function. Okay, I will do a little bit of strange things here, but you need to be patient to see why this is useful. It becomes clear at the very end, but you will be able to follow each one of my steps, yes? So what I do first, strangely, I will factor a factor out. So I will take a square root of a squared plus b squared out of this function, yes? And then what happens, this becomes a divided by square root of a squared plus b squared multiplied by sine x plus b divided by square root of a squared plus b squared cosine x. Okay, so what I have done to see that what I have written is exactly the same expression in a little bit weird way. Why is that true? Because if I multiply this back, this will cancel that one, and what is left here is a, which is exactly this one, and when I multiply this here, this will cancel that one, what is left is b, which is exactly this one. So this is completely understandable, except why I'm interested to do this. You need to be patient to see why it is good, okay? But is that understandable now? I just pulled this strange factor out. And now the point is that I want to understand, so I will take that, let P be a point with coordinates. Let me write it in this way. Consider the point for example, let me call it P with coordinates a divided by square root of a squared plus b squared, and then b divided by a squared plus b squared, yes? This is a point. I am introducing a point, so I took this factor, put it as the x coordinate. I put that factor, put it as y coordinate. So this gives me a point, yes? But my claim is that this point is always on the unit circle. So I don't know anything about a and b. I know that a is a positive number, b is a non-zero number. I am telling you that whatever these numbers are, this point is a point on the unit circle. And my question is why? Why this point lies on the unit circle, on the unit trigonometric circle? So this is the unit circle, for example. Make it better. So why do you think this point, regardless of the values of a and b, is definitely somewhere on this unit circle? Why is that? Or at least tell me, how should I discover if this is true or false? For example, let me just ask you, is the point 1 and 2 on the unit circle? How do you know that? You should be able to answer this question at this level, yes? Is this point on the unit circle or no? Why? Why? How did you understand? You say no.
Because the radius is 1 millimeter.
Okay, and the radius is 1, but the distance from this to the origin is larger than 1. Yes, how can I calculate the distance of a point from the origin? How do you do that? You take the square root, and then you write this to the power of 2, which is 1, plus this power of 2, which is 4, then it becomes the square root of 5. So if I ask you what is the distance of this point to the origin, the answer is the square root of 5. And then definitely square root of 5 is larger than 1. And the radius of my circle is 1, so it cannot be on the circle. In this case, is it outside of the circle or inside? It's clear it's outside, yes? Okay, now the same question. How should I know that? For example, is this point on the unit circle or not? How should I understand that? I raise it to power 2, it becomes 1 over 4. I raise this to power 2, it becomes 3 over 4. I add them, take the square. So it becomes 1 over 4, 3 over 4, which is 4 over 4, 1, square root of 1 is 1. So yes, this point is on the unit circle because its distance to the origin is exactly 1. Is that understandable or not? Okay, now I want to do the same thing. The only problem is here. Here we had some particular numbers, but here I have some algebra to do. But that's the same story. If I want to show that this P is definitely on this unit circle, what should I do? Now can you tell me the process, what I'm supposed to do to show that this point is on the unit circle? Yes? So distance to the origin. How? By I raise this one to power 2, I raise this one to power 2 and add them and take the square root, yes? So let me calculate this O. Let me calculate OP. So as we did before, so this becomes square root of this number to power 2, yes, plus this number to power 2. Yes? If I can show that this is 1, regardless of the values of A and B, then I am done. So, but this algebra is not that hard. It is very simple, actually. So this becomes, if I want to raise this to power 2, it's a fraction. It's numerator to power 2. It's denominator to power 2. I will get rid of this square root sign. And the same thing happens here. But then it is clear that I want to add two fractions. The denominators are the same, so I can take the common denominator and I can add the numerators, yes? But then I have a square root, but this fraction is exactly 1 regardless of what values A and B are. So it becomes square root of 1, which is 1. So we've shown that P is somewhere on this unit circle, yes? Okay, but I don't know where it is, but I don't know it is not on the left side. Why? I showed that it is somewhere on the circle, but now I am claiming more. I'm claiming is definitely it is somewhere on the right semicircle, not on the left semicircle. Why? Yes?
Maybe because the the fractions would be positive since it's to the power of 2.
The denominators are. One more thing, which I have, yes, that's correct. So I have implicitly assumed that A is positive. Yes? So look here, the denominators, as you said, are actually positive because they are square roots, yes? And A squared plus B squared. Between these two, I have implicitly mentioned that A is positive. I don't know about the sign of B. It might be positive or negative, but A has been explicitly mentioned to be positive. So if I ask you, am I sure about the sign of this expression? Yes, you would say this is always positive. Yes, we don't know. This might be positive or negative, but this x-coordinate is definitely positive. When x-coordinate is definitely positive, I have to be on the right side. On the other hand, I have to be on the semicircle. So I would be somewhere here. Yes, somewhere here. Okay, and I cannot be here or there. Yes, why? Because if I want to be here, it means that the x-coordinate is 0. But if x-coordinate is 0, it means A should be 0. Yes, but A is positive. The same story here. I cannot be here. So I would say that, let me make this a hollow circle. and this one a hollow circle. So these are not the points for P. P definitely lies somewhere here. Yes? This is the place for this point. Yes, is that clear? Okay, now, but I don't know more than that. So let us, for example, assume that P is somewhere. For example, let us consider this to be P, that point P. And then let me just take this one and connect it to its origin. And let us take this angle to be theta. This angle theta will be somewhere between minus 90 degrees and 90 degrees. Agree? So if P is here, the angle is between 0 and 90. If P is somewhere here, the angle is between minus 90 and 0. Yes? So, but in general, P is somewhere, this angle theta is somewhere between minus 90 and 90. Okay. And that is unique. So whenever I find this P, wherever it is, I connect it to the origin, and then it makes an angle. If it is in the positive direction, it would be a positive angle between 0 and 90. If it is in the negative direction, it would be a negative angle between minus 90 and 0. And that is for sure. Okay? Okay. But on the other hand, forget about this. If I ask you to write the coordinates of this point now using the angle, what do you write? You would write cosine theta and sine theta. Yes? So on the one hand, this P has these coordinates. On the other hand, if I connect this point to the origin and this angle is theta, we know that the coordinates of this point should be cosine and sine. Yes? So it means that I would say that by this argument you will understand this. There exists a unique angle theta between minus 90 degrees and 90 degrees such that cosine theta is equal to a over square root of a squared plus b squared, and sine theta is equal to b over square root of a squared plus b squared. Okay, I want to wait here. That is my point. Do you understand this sentence? Is that understandable? So by this, I wanted to convince you that there is a unique angle between minus 90 and 90, so that when you calculate cosine of that angle, it becomes this fraction, and if you calculate sine of that angle, it becomes this fraction. Yes? Understandable? Okay, now why this is good, let us go back here. So let us go back here, so let me put this a star, and now from star, and let me write number 1 and number 2. So from comparing a star, number 1 and number 2, we can conclude something. We can conclude that y is equal to this expression, a squared plus b squared, and then instead of the first fraction, I can write cosine theta multiplied by sine x plus the second fraction is sine theta multiplied by cosine x. Yeah, is that understandable? So what I have done, I have taken this away and put cosine and sine instead, and I got this. But I hope that this now sounds familiar, yes? So is this combination familiar? What is that? This is the addition formula for sine, yes? Sine, so I can write it as what? Y is equal to square root of a squared plus b squared sine of x plus theta. Yes? So in principle, if I have a mixture of sine and cosine in this form, this is just a single sine function. So you can write it as a single sine function, yes? It was a mixture of sine and cosine. What I did by this method, I showed that the same function can also be rewritten in the form of one single sine function without any cosine functions appearing there, yes? And then answering more or all questions regarding sine function, so regarding this function would be easy. Because if I ask a question about this function, you change it to that single sine function and then they answer the question in that function, which is easier to work with, yes? For example, let us consider the question that we started from. Do you remember we talked about the maximum of this function? Okay, I will go through the details later, but so on here, A is 1, if I compare it, B is also 1. So if I put this into that formula, 1 to the 2 plus 1 to the 2 is 2, so it becomes the square root of 2 plus sine x plus some angle theta, yes? Now if I ask you the maximum of this function, instead of answering the question here, you can answer the question here. Yes? Do you remember if I ask you what is the maximum of this function, what is the amplitude of this function? What is the amplitude? The square root of 2. So the maximum is the square root of 2. But this function is this function. So if the maximum of this function is the square root of 2, the maximum of this function is also the square root of 2. And that is the answer that we started with, the answer to the question we started with. Do you remember I asked you what is the maximum of this function? The naive wrong question answer was to say 2, but we realized no, it is not 2. The real answer is the square root of 2. So that's the maximum of this function. So this is the benefit of writing this mixture of sine and cosine in terms of one single function. And by the way, do you see if I want to write something below it, this is of those types of functions that we studied, yes? A sine bx, yes, plus c plus d, yes? This is one of those functions we studied actually quite a good amount of time. So if you see this a, this is playing the role of this a. So this 1 is playing the role of this b. This theta is playing the role of c. In this case, d is 0. But if I ask, for example, if I add 1d here, I will write this part as this, and then d will be added to that one. Yes? So what we are doing actually, we are translating, we are changing this function, which is not that familiar for us right now, to a form of function that we have already studied, so and we know about those, yes? And then we answer any question regarding this function by changing it to this form and answering it in this new form, yes? So that is the whole point of this lesson. Okay, but then the point is that how can I practically do that? So if I ask you, can you write this in that form? You don't have any problems here, but you have some problems finding that theta, yes? So you need to know how to find that theta now. So that's what I want to address now. Okay, so we don't need this. Okay, tell me, so let me just repeat. So if I ask you to really write this in this way, so far it is correct. The only missing part is this theta. Of course, I know that theta is an angle somewhere between minus 90 and 90, but I need to know more. I want to know the exact value, which angle between minus 90 and 90. So that's my question. Yes, is that clear? I want to answer that question. Here, I divide 2 by 1. Okay, so let us just divide 2 by 1 side by side. What happens? It becomes sine theta divided by cosine theta is equal to b over square root of a squared plus b squared, and then a divided by a squared plus b squared. Yes? And then this one and that one are gone. So what I get is this one is tangent, and this one is b over a. Yes? But I am looking for theta, and you know that. What is theta? So theta is this tangent inverse of b over a. Yes? So if I want to summarize everything, I would say that y equals to, so let me write it in this way, a sine x plus b cosine x if a is positive is equal to square root of a squared plus b squared, and then you have sine of x plus theta, where theta is tangent inverse of b over a. Or equivalently, you can say tangent of theta is b over a. It doesn't matter. So this is the what we actually got. Yeah, okay, I don't know. Is that understandable, everything? Yes. So it's different from what is written in the book. The reason that I did it in this way, you might look at it might look a little bit strange. The reason that I'm looking ahead, if you go to university, tangent inverse of b over a is a function whose domain is exactly between minus 90 and 90. Okay, so this is something, if you just do it in this way, you don't need to change it when you want to learn it in the future. But if you learn it in the way the book talks about that, you need to change, you need to adjust yourself later. Yes, but here you can just follow this. And the book is avoiding actually what happens when a is negative. So the formulas written in the book are written for a only positive. They are considering a to be negative, a to be positive. They are giving you two formulas instead of one formula. One for positive b, one for negative b. But you don't need to do that. You just need to know this formula. Either if b is negative or positive, it will change this theta accordingly. So you don't need to memorize two formulas. That's just one single formula. And of course, I am also not talking about a negative, but for a negative, we know what to do. What do you think? If a negative, what can I do? So let me not go forward. So let us just go back and solve this problem. If I give you this in the exam, for example, and ask you what is the amplitude of this function, you need to write it for me in this proper way and then say that this number is the amplitude or the maximum. Yes? Okay, so if I ask you what the period is, you can write it in this form, and then you know the period of this function is actually what is 360 degrees. So you can tell that this period is also 360 degrees. Okay, so now let me try to solve some problems for you here. Okay, so the first thing is just let us go back to our motivating starting question, yes? So what I have to do, first of all, I realize that this is this new lesson, this is this function, and you need to read a and b in this function. So a is what? 1, b is also 1. So this means that you need to calculate tangent of theta, yes? If you want to, you can use directly this formula or that formula. Doesn't matter. So let me just use this. Theta is tangent inverse of b over a, which is tangent inverse of 1 over 1, which is tangent inverse of 1. But I hope that at least you know that this angle is famous, yes? So is there any 1 in the column of tangents in that table? I hope that you remember it's 45 degrees. If you don't remember, you either need to go to the table, but at least you need to know that 1 for tangent is a famous number. Or, I don't know, you go to that long table, and then you go to the tangent line and see where the tangent becomes 1, and then read the angle, yes? Or, if that angle is not a famous one, you have to use your calculator. Yes, that's that. But here, I hope that you agree with me. This you should be able to do it yourself. I want to make sure that everyone knows how to get this without calculator to be 45, using the formula sheet and having that long table. Yes? Is that understandable? Yes or no? Okay. So that is 45 degrees. And then what happens? This formula is also in the formula sheet. Okay, so you just reuse it. Okay, so the y becomes equal to square root of 1 to the power of 2 plus 1 to the power of 2a squared plus b squared sine of x plus theta. And then this becomes square root of 2 sine x plus 45 degrees. So that function is this function. Yes. By the way, if you want to discover this formula, it might be a little bit hard, but if you open it, it is a matter of seconds to understand. Yes. Why? I want to tell you that there is nothing mysterious going on. If I ask you, can you go back from here to here? This should be probably an E-level question. Going from here to there is easy. If I ask you to expand that, what do? You write the square root of 2, and then you use the addition formula. So what happens? It becomes sine of the first one, cosine of the second one, plus sine of the second one, cosine of the first one. Yes? And then you replace this number with 1 over square root of 2. You replace this number with 1 over square root of 2. And then when you multiply square root of 2, this will cancel this one and that one. You go back to this function. So going back to that function is actually an E-level question. You just need to expand and put the numbers there. But going in this direction, if you don't know what to do, it might be not that easy to guess for all cases. So that's why we developed a formula, so that we can use the formula to write all of them in that way. Yes, is that clear? Yes or no? Okay, one thing is that I started with x. I could have started with 2x in the beginning, or I could have started with any angle. Yes? The point is that the angle that appears here should be exactly the same angle that appears in front of cosine. So let me just emphasize here. They have to be the same. Yes? For example, if I ask you, can you write this as one single sine function? So for example, y equals to 5, let me write 3, sine 2x plus 5 degrees, for example. And then let me write plus 4 cosine of 2x plus 5 degrees. Yes. Can I use this formula for this? Yes. Why? Because the angle in front of sine and the angle in front of cosine are exactly the same. So I can use that formula. So what should I do? I need to write square root of a squared plus b squared, and then I write sine function, and then I repeat my angle, whatever it is, and then I write tangent inverse of b over a. Yes, is that understandable? So you can write it in that way. But this answer is 5. So if I ask you approximately, this becomes approximately equal this. If I remember, it's around 37 degrees. Around 737 degrees. So might be I ask you to give me approximations up to some decimal points. In that case, you have to write it in this way. Otherwise, you have to stop there. In that case, then it becomes 5 sine of 2x plus approximately 42 degrees. Yes? Something like that. Or if I ask you to write this as a cosine function, what do? This formula only writes this combination as a sine function. But if I insist to write it as a cosine function, then what do? Now this should be famous for you by now. Yes, you subtract 90 degrees from that. Yes, I told you the other time. So sine of any angle is equal to the cosine of its complement. Yes? But for cosine, it doesn't matter if I interchange them. Is that understandable? So what we do we can, if I ask you to write this as cosine, you write cosine and you take this one and subtract 90 from it, so it becomes cosine x minus 45 degrees. So usually I don't ask, but you don't need it because it doesn't matter. There is no difference between sine and cosine. I want you to understand. Sine and cosine are shifting. One of them is the shift of the other one with 90 degrees, either to the left or to the right. Yes? So there is nothing very serious about sine and cosine. Okay. Is that clear? But what happens if A is negative? That book is avoiding that. But it is not a big problem. So assume that I start with negative sine x. So for negative b, you don't have any problems. You see my restrictions. B is not 0, that's it. So it can be positive or negative. It will not affect this argument. But if A is negative, it will affect the argument. Do you know where? I don't know if I erased everything. But do you know where it was important to assume that A is positive in my argument? This will affect if I change A to negative. Yes, Ruben?
In which quadrant?
Yes, so it was on the right semicircle. Yes. So this A is positive comes into the game when I wanted to show you that the point P, do you remember, it lies somewhere on the right semicircle. Yes? But if A is negative, then the point will lie on the left, and the angle will no longer be between minus 90 and 90, yes? So because if I am in the first quadrant, so do you remember this one was related to the x-coordinate, and the denominator is of course always positive. If the numerator is positive, the whole expression is positive. So the x-coordinate is positive, I am on the right side, and if A is negative, suddenly I will be on the left-hand side. But it matters. Why? Because if I am on the right-hand side, then this angle would be between minus 90 and 90. But if I have to be on the left-hand side, this angle would be from 90 to 270. So that angle, the range of that angle will change. Yes? So this is where it is important if A is positive or negative. Even though the book and the exercises don't talk about A negative, but it is not that hard. What happens if A negative is A negative? How should I treat the problem if A is negative? So, for example, I ask you the same question for this. What is the maximum of this function? Then I start with the negative sign. So what would be the answer? So I cannot use this formula because this formula is invented for when A is positive, but A is negative. But the solution is simple. What should I do? I factor a negative sign out. Then this becomes positive. This becomes negative. But this being negative doesn't have any problem, so I can solve the problem. I can find this part using my formula, but whatever I get, I multiply it by negative sign. Yes? So that's also possible. So let us just, by the way, do that here. So what should I do here? So I factored a minus sign out. What is the motivation? Because my formula works only the coefficient of sine is positive. Here the coefficient of sine is negative, so it motivates me to take a negative sign out to make everything right. Now for this function, A is 1, B is negative 1. But B being negative doesn't have any problems. I don't have any problems with that. So I just write this one. So let me write. This minus sign is that minus sign. But forget about that minus sign. For the rest of it, I use this formula. So this becomes the square root of A squared, which is 1 to the 2, plus minus 1 to the 2, B squared. And then this becomes sine of x plus tangent inverse of B over A. And then I can just lift my hand and you see the minus sign. So that would be the formula. Yes? And then let us simplify that. So what happens? This becomes 1, this becomes 1, square root of 2, negative square root of 2. And then this is sine function. this becomes tangent inverse of minus 1. Of course, you know that tangent inverse of 1 is equal to what? 45 degrees. Okay, can you guess what would be the angle whose tangent is negative 1? But you need to name an angle between minus 90 and 90. Yeah, it's simple. It's just minus 45, yes? So it becomes minus 45 degrees. So you can keep it in that. So now, if I ask you the same question, what is the maximum of this function at the end? Instead of answering this question for this function, you change it into this function and answer the same question here. What is the maximum and minimum of this function? Can you tell? What is the amplitude of this function? Yes?
Negative square root.
No, be careful. Amplitude by definition is positive. The reason that book is avoiding a negative because this will make this problem, yes? So be careful. I told you that if I don't know, if you have written, I mainly want to write it as absolute value. So if I ask you what is the amplitude and you answer is minus the square root of 2, it is not correct because by definition amplitude is a positive number. So what is the amplitude now? Square root of 2. So it means the maximum is the square root of 2 and the minimum is what? Minus the square root of 2. Yes, is that clear? Okay, so, but you see that even if this is negative, it doesn't actually make a big problem for you. So you can just, but when I check the book is avoiding a negative. Okay, but there is nothing too serious about that. Is that clear? Okay. So, by the way, if I want to get rid of this negative sign, let us talk a little bit about that. What can I do if I want to see it positive there? What can I do? This you should be able to answer, yes. If I have minus sine theta and I want not to see negative sign here, what can I do? I can move negative sign inside. I can write sine negative theta, yes? So this is one way to get rid of that minus sign there. This is not that good because if I want to continue it in that way, I take this negative sign and move it to inside. For sine it is possible. But when I move it inside, I have to multiply it here and there. So the answer becomes the square root of 2 sine 45 degrees minus x. Yes? So if someone writes that this expression is equal to that, that is correct. If someone writes that this expression is equal to that, that's also correct. But so far, we learned not to make x negative. Yes? So that is correct. That is not wrong. But now I insist you to get rid of this negative sign without affecting the sign of x. Can you do that? So what I'm saying is, I have minus sine theta. One way to get rid of this minus sign is to move it inside. But now I am asking you, write something here. So theta is positive. I want to keep it positive. But I also want to get rid of this negative sign. Then what can I do? Yes?
Sine theta plus 180.
Yes. Yes, exactly. So it becomes sine, the same theta plus 180. This is equal to that. We also talked about this before. So if you want to get rid of this negative sign for sine, you can flip it inside, but then it will change the sign of theta. If you insist to keep the sign of theta as before, you can use this formula. So if I want to get rid of this, so this can be written in this form, square root of 2. I just get rid of this negative sign. Then I would write sine. Then I write x minus 45. Then I add 180 to it. And then of course I can simplify it a little bit more. This one and that one becomes 135 degrees. It becomes equal to that. So that is good to know. I don't know. This will be recorded in the video, so if you forget, you can come back. But this is, by the way, at the level of your mathematics. So you really need to be able to answer these questions more or less fast. Don't rely that much on the formula sheet. So these are the things that you need. So you see, when I ask you a question, how many times you want to page the formula sheet? You need to know where to look for it so that you can find your formula. Okay. Any questions here? So even though for some reason the book has avoided putting A negative, but you see that you don't face any serious problem if A is negative. So it means that we can solve all these problems with just one single formula. Yes? Is that clear? Yes or no? Okay, now let me ask you a little bit more interesting questions. So I want to write this formula here on top so that we can have it. So let me write A is positive here. This formula works in this form if A is positive and B is not equal to 0. Yes. And let me insist to write it in that way and clean this. Okay, so A is positive, B is not equal to 0. This becomes equal to square root of A squared plus B squared sine. Let me combine them in one formula. That is the formula. Okay, now let me ask you one more question. Determine so E-level questions here is just this. I give you a simple function, you have the formula, you write it in the form of sine function. That's it. Example, I would say that let, for example, f of x be equals to 3 sine to the power of 2x minus so let me write it in this way, minus 3 and plus 5 cosine 2x. Okay, determine the amplitude and the period of this function. Okay, so this is a little bit higher level question. Let me see if there are some of them in the book. I don't see that in the book, but yeah, but you can solve it. I don't think you have a problem. So what we are supposed to do here? First of all, it is not directly related to what I taught today. Yes, because I have a power of 2 here and the angles between sine and cosine are different. Okay, so what can I do? One thing is clear. If I want to write the formula for cosine, I don't know, might be you have some guess what to do, but if you go and refer to the formula sheet, you will have 3 formulas for sine. So what can you write? You can write it as cosine squared x minus sine squared x, or you can write it as 2 cosine squared x minus 1, or you can write as 1 minus 2 sine squared x. Yes. I don't know, I haven't thought about that. Might be one of these also works. Yeah. So might be the last one also works here, yes? Because if I use this one or that one, if I use this one, I will have a mixture of sine squareds and cosine squareds, yes? If I use this one, I have sine squared here, I will have also cosine squared here. Then again, I will have a mixture of sine squared and cosine squared. If I use this one, then the function would be something actually related to only sine function. So that is one way to do that. I will come back and probably solve the problem using this formula as well. But there is also another formula when we studied, yes, that was under the title of the half angle formulas or something. So we learned that sine squared of any angle, of course, do you remember I told you that sine squared can be written as in terms of cosine squared using the Etan formula, yes, or you can use this and write this formula. This is equal to 1 minus cosine 2 times that angle divided by 2. And in the book, it was written this, and they have taken this out. So they called it half angle formulas. Yes? So, but let me just take these 2 away here and put 2 there. So this is the formula that I want to use for the first part of the problem. And you see what is the motivation behind that. So what can we do? We can write f of x is equal to minus 3 is just minus 3, and then instead of sine squared x, I can use this formula. So this becomes, let me write 1/2 here instead of putting 1/2 in the denominator, and then I will have 1 minus cosine of 2x. And then I continue the problem as it is. I think this is a good example, but this is not related to this topic, sorry. This can be solved much easier. So if you realize this formula, you can actually answer the problem, because you know that you can answer these questions about the amplitudes and period if you don't have that mixture. So the strategy is to get rid of the mixture of sine and cosine and write it as either sine or cosine. And it is better to get rid of powers, because the reason is that at the level of your mathematics, you haven't studied this function. Yes, we have studied this function. So it means that it is better to avoid the power of 2 if possible most of the time. So actually I did that one. This is a good example, but not probably that related to this, because this can be now solved easily, yes? How can I answer this question? I multiply this minus 3 over here, it becomes minus 3 over 2. The next one becomes positive 3 over 2 cosine 2x. Yes, and then I have 5 cosine 2x. And of course this is now very easy. This becomes 3 over 2 plus 5 is 13 over 2 cosine 2x. And this is minus 3 over 2. So is that understandable? So the function that I ask you to find its amplitude and its period, you were able to write it without any mixture of sine and cosine. It is written solely in terms of cosine 2x. And then if I ask you what is the amplitude of this function, do you remember? You can compare this form by this function. Yes, do you agree that the function on the board is of this type? Yes, if I ask you what a is, you compare a is 13 over 2. If I ask you what b is 2. What c is 0. What d is negative 3 over 2. So this is exactly the function that you already know how to answer questions related to that function. So now can you answer me what is the amplitude of this function? What is the amplitude of this? 13 over 2. So if I ask you what is the maximum, you would say 13 over 2. What is the minimum? Minus 13 over 2. Okay, and then if I ask you what is the period, do you remember there is a formula for the period which is related to this coefficient? the period is 360 degrees divided by b. In this problem, b is 2, so the period is, so I would say that the amplitude is 13 over 2 in this problem, and then the period is 180. So the period of this function is 180, and the amplitude of that function is 3 over 2. Yes? So we don't need to go back and solve it in this way. There's no point for doing that. Yeah, I insist to do it a little bit with this one because let me see how it goes. For the period you will have problems because you don't know the period of this function if I have a power there. Yes, but for amplitude, let us see what is your opinion about that. Assume that, because probably I know that in this, from pedagogical point of view, usually people immediately find the formula for cosine 2x, but not that easily find this formula, okay? So, might be, if I give you this and you want to solve that problem, then what can I do? I can write minus 3 sine squared x. Probably, you will immediately find this formula in the formula sheet and replace it with that. So it becomes 5, and then you write 1 minus 2 sine squared x. Yes? And then, of course, I multiply and simplify. So 5 times minus 2 is minus 10 sine squared, minus 13, it becomes minus 3, it becomes minus 13 sine squared x, and then you have plus a 5. Now I see a little bit of discrepancies here. This is now very... okay. So I have asked about the amplitude, by the way. I was a little bit worried about what is happening here. If I ask you about the amplitude, that is the correct answer. But if I ask you what is the maximum? What is the maximum? What is the maximum of that function? So I ask you about the amplitude, and I solve it in that way, compare it with this one, and I found the amplitude. But the amplitude in this case is not equal to the maximum. Yes? Yes, Jakub?
13.
How did you find that?
I just guess.
No, because the amplitude is how much the function is going high, up and down related to the equilibrium point. Yes? But the equilibrium point is minus 3 over 2. So if I ask you what is the maximum, be careful. There is a difference between maximum and minimum if I have this shift. Yes? Do you remember the role of this d is to take your function, move it upwards or downwards, yes? The amplitude will not change if I take my function, move it up and down, but the highest points and the lowest points will change by this shift. So if I ask you what is the amplitude, you answer 13 over 2, that is right, but for this function, because I have a shift, if I ask you what is the maximum and you answer the same thing, that is wrong. What is the maximum, can you tell me? 10 over 2, yes? 13 over 2 is the maximum of this part, which is shifted 3 over 2 down. So the maximum is how much? It's 5. Yes? What is the minimum? Can you tell me? Minus 13 over 2 minus 3 over 2, which becomes minus 8. Yes? So the minimum is minus 8, the maximum is 5, but the amplitude is 13 over 2. Yes? Is that understandable? Okay. Now, if I ask you what is the amplitude here, this is hard to answer because this is a sine squared function. We have already studied these kinds of functions. Yes? But if I ask you what is the maximum and minimum, you can answer. Can you tell me what is the maximum here? If I want to make it maximum, I should make it as small as possible. Yes, because I have a negative sign. If I increase it, I will increase the negative value, then I will lower the function. So if I want to make it maximum, what should I do? I have to make this part as low as possible. Yes, is that understandable? Okay, what is the lowest value for this? What is the lowest value for sine squared x? Zero. Yes? Because this is to the power of even, it cannot be. So the minimum value of this is 0. So if I replace it with 0, then I get 5 as the minimum of my function, squaring with what my result here. That's my maximum function value. Yes? And then if I ask you what is the lowest value for this? You want to make the whole combination as low as possible. So what do you do? You need to make this part as big as possible, yes? Because there is a negative sign. You want to make the whole expression as low as possible. You cannot change this 5 is constant. What you have in your hand is to play around with this variable part. But you want to make it as low as possible. So you need to increase sign, so that when you increase sign, by this negative sign, it will be decreased and it makes it lower and lower. But what is the maximum of sine squared? Yes? 1. So it becomes minus 13 plus 5, and then you get again the answer minus 8, which is exactly the thing that we got it from here. But you see that if you write it in this normal way, it is easier. You don't need to understand things deeper. You can just immediately calculate them according to what you have learned so far. Okay, any questions here? Okay, so I think I will stop here. So there is one thing left, radians, and then trigonometric equations. Trigonometric equations is the most important part. Sometimes I said that the hardest part. No, that was wrong. It's the most important part, because you need to solve trigonometric equations and try to find the unknown values sometimes. That is very, very important for us. So, and then we will be ready probably for the exam, yes? Any questions? Okay, thank you. So I will stop here and then you can work on yourself. So these are, I will write them on Google Classroom right now. It is under the title of sum of two trigonometric functions, and there is a section of exercises. 6 exercises are in the book.